You may have seen a magnet of a shape like this or that before. We'll talk more about this shape, but first of all, what is a magnet? A magnet is a material or object that produces a magnetic field and can attract or repel magnetic materials. Two things from the definition: magnetic field and magnetic materials. A magnetic field is a region around the magnet where the force of the magnet can be felt. A magnetic material is a material that experiences a force when placed in a magnetic field. So putting things together, there is a force, there is also an attraction or repulsion of other magnetic materials. A magnet has two poles, a north pole and a south pole. If a magnet is supported such that it can swing, it will come to rest with one end pointing towards the earth north. That end of the magnet is referred to as the north seeking pole or north pole. The other end is referred to as the south seeking pole or south pole. The magnetic force seems to come from these 2 points. The force is therefore stronger at the ends. When a magnet is dipped into iron filings, the iron filings are attracted mostly to the ends of the magnet as shown. Common shapes of magnets: we have bar magnets, horseshoe magnets, and circular magnets. Law of magnetism. It states that like poles repel, unlike poles attract. A north pole will attract a south pole, and a north pole will repel a north pole. So will a south pole repel a south pole. The force of attraction between magnetic poles decreases as their separation increases. There isn't much impact felt when the distance of separation is small. But as they come close together, there is strong repulsion between them. Let's consider magnetization. It is a method or process of developing the properties of a magnet in a magnetic material. A magnetic substance can be magnetized by using induction, stroking, or by electric currents. Materials that are difficult to magnetize but are able to maintain their magnetism are referred to as hard magnetic materials. An example is steel. Materials that are easy to magnetize but easily lose their magnetism are referred to as soft magnetic materials. Materials that are not attracted to a magnet are non-magnetic materials. An example is plastic. These materials cannot be magnetized. How then does the magnetization occur? First, let's consider induction. When a piece of unmagnetized material touches or is brought near to the pole of a permanent magnet, it becomes a magnet itself. So we say magnetism is induced. The induced pole nearest the magnet is the opposite of the pole at the end of the magnet. If we bring another material close to the first one, magnetism will be induced and the poles will be induced such that the top of the second will have a polarity opposite the end of the first. Steel and iron will behave differently when brought to a magnet. After they are pulled away from the magnet, the steel keeps its induced magnetism and becomes a permanent magnet. The iron loses its induced magnetism, and as a result, they are used for temporary magnets. Stroking method. The steel bar is stroked with the same pole of a permanent magnet from one end to the other in one direction. The magnetic particles in the material become aligned and north and south poles are induced. If the north pole is used in stroking, the end of the bar where it started becomes the north pole and the opposite end becomes the south. On the other hand, if the south pole is used for the stroking, the end where the stroking started from would become the south pole. The type of stroking shown here is the single stroking or single touch method. Electrical method. A ferromagnetic material is placed inside a solenoid and a direct current is passed into the solenoid. The solenoid is a coil of wire. A solenoid becomes a magnet. The steel bar placed inside a coil becomes magnetized due to the magnetic induction from the solenoid. To determine the polarities, we use the direction of current flow. When viewed from one end, if the flow of current is clockwise, then that end of the steel bar will become the south, and the other end will be the north pole. If, on the other hand, the direction of current flow when viewed from that end is anti-clockwise, then that end will be the north pole. The opposite of magnetization is demagnetization. Whereas magnetization is causing a magnetic material to become a magnet, demagnetization is a process of causing a magnet to lose its magnetism, or the process of removing magnetic field from an object. Like mentioned earlier, magnetic particles are lined up in a magnet, but when it is demagnetized, the orientation of the magnetic particles are destroyed. Causes include passing an alternating current around the magnet, dropping the magnet on the floor several times, heating the magnet to a very high temperature, and hammering the magnet several times. So that is good introduction to magnetism. The next video will touch on other aspects of magnetism. See you in the next one.